In section 5.4, we're going to look at polynomials and several variables. So in the first example, we've got 2x squared y minus 5y plus 3. We're going to evaluate it for x equals 2 and y equals negative 3. So we start off with 2 times x squared times y minus 5 times y plus 3. And we're going to simplify this using order of operations. 2 squared is 4. 4 times 2 is 8. 8 times negative 3 is negative 24. Negative 5 times negative 3 is positive 15. Plus 3. So let's see, negative 24 plus 15 is negative 9. Plus 3 is negative 6. So my final answer on that one would be negative 6. In objective 2, understanding the vocabulary of polynomials in one or more variables. With more than one variable, when we talk about degree, as we talked about in one of the previous sections, the degree of a term with more than one variable is the sum of the exponents on the variables. So let's fill out this chart right here. In the term 9x cubed y to the fourth, the coefficient is 9 and the degree is 7. That's the sum of the degrees of each of the variables. In the next one, the coefficient is 8 and the degree is 3, 2 and 1. And in the last one, ABC, the coefficient is 1 and the degree is also 3, 1 on each of the three variables. Let's determine the coefficient of each term, the degree of each term, and the degree of the polynomial. Okay, so let's make a chart right here. We'll list the term, very similar to the chart above, the coefficient, and the degree. Right, in the first term is x squared. The coefficient is 1. The degree is 2. In the second term, negative 10xy, the coefficient is negative 10. The degree is also 2. And in the third one, 4y squared, the coefficient is 4. The degree is 2. Now, from our definition before, the degree of the polynomial was the degree of the largest degree of any of the terms. So the degree of the polynomial is 2. Now you can see that writing things in descending order isn't going to make sense in a multivariable case because I can't write them in order of lowest degree or highest degree to lowest degree because all of these terms have degree 2. How do I know which one to go first? Generally we'll write them in alphabetical order if that's the case. But again, there's not a general form or descending form I can use for a multivariable polynomial. Okay, let's make our chart here again. We're going to look at term, coefficient, and degree. Okay, the first term is x cubed y squared. The coefficient is 1. The degree is 5. The next term, negative 5x squared y to the 7th. The coefficient is negative 5. The degree is 9, the sum of the degrees of x and y. In the next term, 6y squared. Coefficient is 6. The degree is 2. And in the last one, negative 3. The coefficient is negative 3. It's just a constant. So the degree is 0. So in this case, the degree of the polynomial, is 9. That would be the highest degree of any of these terms. Right, in the next example, we're going to just combine like terms to add or subtract these polynomials up. Here I've got addition, so let's just go ahead and add like terms. 4x squared y plus negative 2x squared y is 2x squared y. 8xy plus 5xy is plus 13xy. And 11 plus 2 is 13. In the subtraction case, I better make sure that I distribute this negative before combining my like terms. So let's rewrite this as x cubed plus 7xy minus 5y squared minus 6x squared plus yx minus y squared. For like terms, there's nothing like x squared, so I'm going to write the x squared. There's nothing, my bad, let me erase that real fast. I meant to say there's nothing like x cubed, which is my leading term here. There's nothing like x cubed, so I'll write the x cubed. Oh, there is. I copied this down wrong. That was an x cubed. Alright, let's see if I got everything else right. Everything else does look right. Alright, so in this case, x cubed minus 6x cubed is negative 5x cubed. There we go. 7xy and yx are like xy and yx, just the order that's different. Everything's the same. So we'll add those to 8xy. And then negative 5y squared minus y will be negative 6y squared. Okay, and that's simplified now. Alright, and then we'll look at some multiplications here, using the distributive property or multiplying monomials together. 5ab squared times negative 3a squared b will be negative 15 a1 plus 2 more is 3a cubed b cubed. 2 and 1 more is 3. Alright, there's no distributing to do here since there's just one term each, so multiply them together. 8 times 3 is negative 24. X to the 3 and 2 is 5. Y to the 9th. Okay. In the next two examples, there is distributing to do because there's more than one term inside the parenthesis. So we're going to get negative 15 x cubed y plus 35 x squared y squared minus 45x y cubed. Okay, in the next one, again, distribute because there's an addition, two terms inside the parenthesis. 4 times 7 is 28, a to the third, b to the fifth, adding the exponents on the a's and then again on the b's, plus 8, a squared, b cubed. And the last two. Okay, I remember I can't do a square on a binomial without writing it twice and showing the distributing process. Okay, so I'm going to write 3t minus 5w twice, and we're going to multiply 3t by 3t. That's 9t squared. 3t times 5w be negative 15tw. 5w times 3t is again a negative 15tw. And a negative 5w and a negative 5w multiplied to a 25w squared. Okay, so when I combine like terms, I get 9t squared minus 30tw plus 25w squared. Okay, and then our last one here, one more distribute. Let's make sure we multiply 5x times 3x, 15x squared, minus 30xy, minus 12 yx, xy, let's just write them the same. Alphabetical order is a good order, plus 24y squared. Okay, so I'm going to end up with, I do have like terms to combine, but 15x squared minus 42xy plus the 24y squared. And again, in the absence of descending order, we go alphabetical. So we write the highest power of x, next lowest power of x until I run out of x's. Then I start taking on any y's I've got left over.